here to talk about the MCP registry. For many people, registry is often synonymous with some sort of centralization. So the theme of the talk here is how we're not fully centralizing everything. We're empowering a whole lot of decentralized discovery here, and we're going to get into what that means here as we step through things. First, who are we? My name is Tadas. I'm here with Toby. We're two of the 4 maintainers of the MCP registry, and we're members of the MCP steering committee. I'm from PulseMCP, where I'm a co-founder, and I do all kinds of MCP-related things. The primary ones are I manage PulseMCP server directory, and I write an in-depth weekly newsletter on all things going on in MCP. And Toby here, he's on the GitHub side. He's head of MCP over at GitHub, and he's famous for maintaining the GitHub MCP server and more recently the GitHub MCP registry. So the scope of our talk here today is we are talking about that REST API for MCP servers that David mentioned in his keynote today. But it's, again, this is the REST API. It is the open source project. This is totally community led. There's no one specific company behind this, where there's a bunch of us all collaborating from the community to put this together on behalf of the MCP community, on behalf of the steering committee. It lives at registry.modelcontextprotocol.io. And there is no official UI at this point for the registry. So if you see some UI, it's probably a community-built implementation just on top of the official registry REST API. As we'll talk about today, not sure exactly how much value there is in a UI on top of the raw registry, on top of the raw REST API. I'm going to talk a lot about this sub-registry concept that we'll get into in the next few slides here. So quick recap of recent goings-on with the registry. On September 8th, just a few weeks back, we had a big live launch preview in preview mode for now. As we found the last few weeks, there's still a lot of rough edges. So if anyone's been implementing on top of it, we apologize for the weekly breaking changes that we've been pushing out. But it is available, and you can hit it. You can hit that API at that URL on the last slide. In the next week or so, we hope to thank you to all the great community feedback we've been getting and all the people publishing and consuming. It's been super helpful to get to a place where we feel like in about a week, we'll be able to say, hey, the API shape is mostly frozen. We don't anticipate breaking changes in the near future. And we'll be in a place where people can start more reliably building on top of that, building production systems on top of it. After that freeze, our goal is going to be to push towards a general availability launch. We don't know exactly what that's going to look like yet. We'll probably be making a list at some point in the next couple weeks as to what are the items we need to hit to make sure we get there. But I think some of the themes will be, number one, stability. That's the most important thing. And then there's a backwards compatibility story that I think we need to work on in terms of there will be breaking changes in the future. How do we manage the ecosystem to not fall apart every time we make a change to the registry? Some shout outs to a few folks that have been instrumental in getting us to that point from the last slide. But Adam and Rado are recent newer maintainers on the registry, and they've put in countless hours. Adam from Anthropic and Rado from Stacklog, they've put in countless hours especially leading up to that preview launch a few weeks back. So huge shout out to them. But then also a handful of other community members have been regularly contributing. So Pri from Last9, Joel from NuGet, Connor from VS Code, Avish from Microsoft. Huge thank you to all of you, as well as the one or two one-off contributions from a bunch of different folks. We're at 45 different contributors here. So thank you to the community for really making all this work possible. So before I jump into the details, the meat and potatoes of what I want to talk today, I just wanted to give you a quick run through of architecture. For those of you who haven't engaged with the registry before, this is how we envision the ecosystem kind of coming together around this registry. So step one, the most obvious kind of starting point is you're a server developer. You will push your information about your MCP server to the MCP registry. And usually this will be in some sort of CI/CD process. So you'll basically set it up once and kind of forget about it. And it'll just run in the background here. But that's the kind of starting point. That's where the data comes from. It's from the server maintainers. And then this is where the decentralization starts to come in from the theme of the talk. We're still expecting there to exist a whole slew of what we call sub-registries built off of this upstream registry. So they're going to exist. I'll talk a little bit more about why, where they're useful later on here. But the point here is that even though these sub-registries will exist, the new thing here is that they will have this common foundation to pull from the upstream. So when you're looking at data from the Anthropic sub-registry versus the GitHub sub-registry, you know they are talking about the same MCP servers from the upstream in some way, but they might augment and look at that data differently. And then, from these sub-registries, you have the MCP clients. So like the end goal is to surface these MCP servers in these MCP clients and get them installed and used. And so those MCP clients will be pulling from some sort of sub-registry. Those sub-registries might exist as separate things. MCP clients can choose to implement their own kind of baked-in sub-registry per se. That's an option. But ultimately, the goal is to get to these MCP clients, of course. And then there's also this separate kind of flow, the previous slide was more about the kind of public-facing MCP clients and sub-registries. Then there's this whole world of enterprise solutions, right, where they'll mix and match public and private data, but they have a whole different set of concerns like governance, procurement, security, that kind of thing. And there's a whole set of gateway type solutions that are in that space, and I'll talk a little bit more about that too. That's the kind of landscape of what we're trying to go for here. Now, here's a big thing as we get into the details here that we're introducing here is this concept of a server.json file. This is like the new standardization effort that is at the heart of a lot of what we're empowering with the registry. And basically from that last diagram, this is like the file that moves from step to step. So if you're a server publisher, you have a server.json file, you get that to the upstream registry. The upstream registry is pushing out server.json files. So I think this is the kind of the static, put simply, it is the static definition of an MCP server that we are passing around from system to system. And this static thing, it will do basically give us four benefits that I'll walk through step by step here. The first benefit is server identity. So when you look at a server.json file, you know what server we're talking about. There's no ambiguity. Oh, is this the official Notion MCP server? Is this the unofficial one? You will look at the server.json file and you'll know what server you're talking about. Second is the capabilities of a server. When you look at a server.json file, you're going to understand what that server is capable of. Like what is its scope, who's it meant for, and so on. Third one is location. Where does that server live? That can mean for a local server, can mean what package registries the source code lives on. For a remote server, that means what URL can you find it at. And lastly, configuration. So beyond knowing where it is, how do I install it? How do I connect to it? What headers do I need to send in a remote call? So I'll dig into this example piece by piece, but just kind of put together a sample server.json file for a theoretical Microsoft's Playwright MCP server. But starting with identity. So identity is largely based on the idea of a name plus a version. A name plus a version is what we're calling a server. So if the version changes, you go from version 1 to version 2, that is effectively a new server because the name and the version has changed, or the version has changed in that case. The name is composed of a namespace, which we're using this reverse DNS name scheme for, which kind of, and when we use it that way, it forms this trust building block. So when you see com.microsoft in a name, you know Microsoft.com owns that MCP server, and so you can trust it to the degree that you trust Microsoft to manage its services. So then there's capabilities. And the simplest form of capabilities is this free-form description. So very simply, you write a sentence of what your server does, and that lives in the server.json file. And when you're looking at a server.json file, you can see, oh, this is what this server is meant to do. There's also this kind of idea of implied capabilities within the rest of the structure. So for example, and this is useful if you're let's say you're a client, you're an MCP client that only supports running MCP servers that can be run by a node and NPM. Then you can kind of understand by looking at a server.json file that, this server can be run via NPM, or it can't. And so you might filter it out or decide to include it for users based on that. So it's another kind of vector of capabilities that you can understand just by analyzing a server.json file. We're going to add other stuff to this. So this is just kind of the starting point. So for example, we're looking at introducing static tool definitions as something like, oh, before you start the server, you might have a good sense for like what tools it might expose at some point in its runtime. So expect more out of this, but this is the kind of bare minimum we're starting with. So location, like I mentioned, location can mean two different things. It can mean where do I find, for a local server, it can mean where do I find the actual packages. So is it on NPM, is it on PyPy, and like what is the version and name on that external system. For remote, it's more simple. It's just what is the URL and what is the transport we're going to use to connect to it. And then lastly, configuration. This is probably the most complex part of the server.json file, but like what are the different ways in which, what are the CLI flags that I can introduce into when I'm running this local server, for example. And then, or like environment variables as well. This is where that would be codified. And then on the remote side, it's more like, what are the query parameters, or what are the headers that we need to introduce? Like if you need to bake in an API key into the connection string of some sort, or into a header, you can catalog this in this section for configuration. So that's the server.json file. Back to the sub-registries. Why do we need this? So like, why not just have one single main registry that just serves every MCP client directly? The key reason for this is that MCP, for many of us, especially early adopters, like MCP has been this great dev tool and very focused on local servers and development workflows and so on. But as you've heard from all the keynotes today, MCP is going to expand far beyond that and already is expanding far beyond that. And so we think that discovery and MCP server selection is a very hard problem. We don't think that we can solve it with a ragtag group of a handful of open source maintainers volunteering our time. And so we wanted to empower this rich ecosystem of different people in different industries, different verticals, each who might have their own take on what does it mean to discover, select, compare, choose MCP servers. And so we're not trying to replace that ecosystem, we're trying to empower it. And so at the end of the day, like if you take a step back, like the goal is every MCP client will need some sort of sub-registry. And in theory, it could be as simple as this, where Claude has one sub-registry and VS Code has one sub-registry. The reality is, for like those kind of products and owned by those companies, there's going to be all kinds of cross-cutting concerns. So like Anthropic might have a sub-registry that serves both Claude Code and Claude.AI and manages it with like the kind of like deep platform integration that a product stack like Anthropic's might have. Same thing with GitHub and VS Code and Copilot CLI. And then you might even have another set of like services like PulseMCP, which we don't have our own products, but we might work with MCP clients to help either serve as their or augment their own capabilities as a sub-registry. So we're creating this kind of middle layer of an ecosystem that serves this purpose. Then there's like, again, there's like this separate world of private sub-registries that will largely be where the enterprise lives. And like that ecosystem will be served by a whole different set of products and tools like ToolHive from StackLock or OBOD or Cloudflare's MCP server portals. There's a whole world there being built as well, and that's separate from all this public stuff that I was talking about on the other slide. So kind of pulling it all together, for server devs and maintainers, what does this mean for you? The primary takeaway is you have one place to publish your MCP servers, one CI/CD process that you need to set up, set it and largely forget it. And then what that means is that solves the need for you to go around to everyone, to each website where your MCP server might be registered, and announce your description changes, your installation instructions. If you add a new environment variable, you don't need to go and update it everywhere. You just update it in your CI/CD process, and it gets out to everyone. It's up to all the sub-registries to pick up that update, vet it in whatever way they see fit, and then propagate it to their systems downstream. And then another kind of implication of what this solves is, if any of you have built an MCP server, you probably have a very long, complex README that says, here are my 15 different target MCP clients, and here's a little JSON blob of how to configure it in Claude Desktop versus VS Code versus Cursor and so on. By introducing this structure, that means all you need to do is maintain your server.json file, and everyone else can pick it up from there and manage that in a very structured, repeatable, reliable way. For MCP client owners, if you're here and you've built or maintained an MCP client, what does this mean for you? For you, it means you get that structured source of truth on the other side of the equation, of the server maintainer equation. You're going to be able to configure any MCP server with some input from the user when they need to provide, say, an API key or so on, but you have a structured kind of path and a very predictable kind of user experience flow you can build on top of that source of truth. So one nice implication of this is by looking at a server.json file, you will immediately be able to understand, can I run this? How can I run this? Like I mentioned earlier, if you only run MCP servers with, say, Node, you'll be able to immediately skip the ones that you can't. And then there's the kind of previously the impossible problem of trying to scrape the web to figure out what MCP servers exist because there was no place to even have that starting point. Now we have that starting point. And you still have to, like with the sub-registry part of the architecture, you still need to either partner with one or implement your own of some sort. But at least now you have this reliable, universal starting point from which you can filter down to the things that you're going to want from the MCP server ecosystem. So I'm going to hand off to Toby to walk through some hands-on demo of all this stuff.
Thank you, Tadas. So while we get this set up, like Tadas said, you're usually going to publish your MCP server with a CI/CD workflow. But we do have a command line tool as well that will help you do this. And so the key part that Tadas talked about was the server.json file. And so with this MCP publisher command, you can actually easily create one. So it already exists, and it will give you a template that you can go through and start filling out for your server name. So you'll see that it's got this io.github, your username, your repo. So you'd replace all of this with your information. If it's a local MCP server, you would use your npm command or your docker command or whatever you're looking for. You'd have your remote server in there. And so for the demo, I have this very small MCP server that I wrote called Mirror that uses reflection or sampling to do reflection for LLMs. And so if we do this, we're going to have to log into GitHub. The command line tool will take me through the login flow. We'll say that, yes, I am me. And so by doing this, it allows me to publish any MCP server under my namespace. And so if we look at my server.json, we'll see that it's io.github.toby/mirror-mcp. So if you have a repo on GitHub, this is the structure that you'll use. And then you'll go through this OAuth flow, and they'll give you permission to publish anything from your own username. So let's bump a version. I have this one published to Node. So we'll do a new Node version. And while we're doing this, we're going to demonstrate this going downstream to PulseMCP. And earlier this morning, Tadas and I published a version 7. And I'm going to bump this to version 8, and we're going to see it flow from the open source registry down into the PulseMCP sub-registry. So now we've got version 8 published to NPM. I'm going to edit my server.json, and I'm going to match that. So we're going to say version 8, and then in NPM, it's also version 8. And all of this stuff gets verified. So if I were to say like version 9, it would give me an error. So I actually do have to publish something that's inside of NPM. And so now that I've logged in, I can say, just publish. And it's going to pick up the server.json. And just like that, it published version 8 to the open source registry. So now I'm going to let Tadas do his magic PulseMCP admin command to suck it in.
Yeah, so now it lives in the upstream. And so the guidance we're giving all these sub-registries is you should pull it down about once per day. There's not a huge need to do a much more thorough process. But right now, I'm just going to kick it off manually here so we can kind of see the process going to the end.
And while we're demonstrating this in PulseMCP, you can imagine this going into the GitHub MCP registry, into the Cursor MCP registry. And again, this is like publish once, show up in many places. And then these downstream registries will probably often enhance the data with platform specific. So in GitHub, we're going to show star count, for instance. We're going to have the README from the repo show up in our registry. And then, like Tadas said, deep platform integration. So one-click install into VS Code, into Visual Studio, things that belong into our ecosystem. And then this gives each of these sub-registries a really nice way to tie closely into their own platform. And
yep, and
we got version 8.
It worked. So version 8 is now fully downstream. We pulled it from the upstream, and it's showing up on our website. And if you hit our API and you're using our API, you would also see it having come through. So jumping ahead here, we'll post these slides here. But David mentioned there's a .well-known thing in the works, and this is roughly how we think it would work, where you would have these server.json files at a well-known URI. We had a little example here of how it could be useful when an agent discovers an MCP server on a website. This is like an alternative flow to using the registry that this work will enable us to build next. We love contributions, so anyone who is into contributing to this volunteer effort, we would love to get you involved. But thank you everyone for listening, and if you want to take a screenshot of these links. At PulseMCP, we love working with companies in the MCP space for paid collaborations and other marketing collaborations. And Toby here with GitHub is working on getting their MCP registry integrated with this upstream registry coming soon. And
it's currently curated, but when we go GA with the open source registry, we'll start ingesting. So we'll allow self-publication into the GitHub MCP server. And also, please join the Discord. So we have a registry working group channel in the MCP Discord. And if you have an idea or you want to collaborate, it's great to go in there and just drop a line first. And then we can tell you if there's like competing initiatives or if you can team up with other people who are working on the same stuff. So we'd love to hear from you.
Thanks, everybody.